going to be focusing on in section 8.1 is greatest common factors. You probably remember hearing the term GCF before, back in your middle school days. Okay. So, let's first write down factors.
Can you go back to the title page, please?
Factors and greatest common factors.
Oh, not in his house. Oh,
So all of chapter 8, we're going to be getting into the world of quadratics. But before we can get into the world of quadratic equations, we need to talk about how to factor something. Okay, so before we can learn how to factor something, we need to actually understand what it means to factor, or what a factor is. So, the factors of a number. What we're looking for is the whole numbers that are multiplied to get a product. Key word here is the word product. Product means when we multiply things together, right? So if I wanted to find all the factors of 12, what would they be? So 1 times 12 are factors. 2 and 6, and then 3 and 4. So that would be my list of all the factors of 12. So 1, 2, 3, 4, 6, 12. Okay. So far, so good.
Yep.
All right. So now, if I wanted to take something to its prime factorization, we have to think about what prime numbers are. So when you take something to a prime factorization, it's when all the factors are prime numbers. So when I say the word factor, in your head you should be thinking of a number that multiplies with another number. So a monomial times a monomial would be factors. Remember that a prime number only has two factors, a number of 1 and itself. We have to remember that 1's not a prime number. So for example, 2 is a prime number, right?
Yeah.
It's not a prime number.
Why?
Because it's not a product of 1 and, well, 1 times 1 is. 1's not a prime number because it's the identity of everything. Because when you multiply anything by 1, it would work for, like 23 or 22. I could do 1 times 22, but 22 is not a prime number.
So what is it?
It's a composite number. We call it composite. So let's quickly come up with a list of prime numbers. 2, 3 is 4 prime? No, because 4, 2 times 2. 5 is prime. 7 is prime.
11.
9's not, because 3 and 3.
Oh, 11.
11.
13.
13. 10's not, because of 5 and 2.
17.
So 10, 11, 12, 13. We already got 14, 15, 16, 17. 19.
23.
23. Okay, we won't go any higher. Well, we should be able to get our prime factors down to numbers that are smaller. Is what?
1 million and 1.
I don't know. Maybe. Okay, so those are prime numbers. So if I wanted to do a prime factorization of 98, do you remember doing factor trees?
Oh my god.
Yes.
Do we have to do that?
That's what we're going to do.
Factor trees are my life.
Good. So if I make 2 branches off of the number 98, someone give me any 2 numbers that multiply to get to 98.
2 and
1 and 98.
2 and
49.
49. Good. Is 2 a prime number? Yes, so that's done. Is 49 a prime number? No. So I'm going to make 2 branches off of that. Two numbers. 7 and 7. Are those prime numbers? Yes. So for my prime factorization, 98 is equal to 2 times 7 times 7 would be the prime factorization. How else could I write that so I could write less? 2 times 7 squared. Good. 2 times 7 squared would be the prime factorization of 98. Okay? So if you're taking prime factorization, you're going to do your factor trees and take it all the way down to prime numbers. So everybody got that? All right. So do it for 30. See if you can figure it out. Prime factorization. Did anybody do 3 and 10 for their first 2 branches?
Yeah.
Doesn't matter, no. 2 and 15. So it would be 2 times 3 times 5 would be your prime factorization. Yes.
So for this, is there a specific order?
You put smallest to largest. Yeah. All right, what if I asked you to do the prime factorization for the number 33? 3 and 11, so the prime factorization would be 3 times 11. Do smallest to largest, right? So 33 is 3 and 11. Both of those are prime numbers, so your prime factorization would be 3 times 11. Okay? All right, so we're good with prime factorizations?
Yep.
All right, now let's talk about GCF, the greatest common factor. Greatest common factor. So I'll probably say GCF very often. So when you hear me say GCF, that's what I'm talking about, finding the greatest common factor. So the greatest common factor is the greatest factor that is shared between 2 or more whole numbers. So we're looking for the greatest factor that is shared between 2 or more whole numbers. So you know how to come up with the factors of a number. So now you should be able to find the factors of 2 numbers or 3 numbers. And then from there, find the greatest factor that they both have in common, which would be your GCF. So we wanted to find the GCF of 12 and 32. What are my factors of 12? 1, 2, 3, 4, 6, and 12. Would be my factors of 12. Okay. Now let's do the same thing for 32. 32 would be 1 and 32. What else? 2 and 16. 4 and 8. Anything else? So my greatest one that they both have in common, there's no, yeah, 16. That's a 16. That's okay. So my GCF of 12 and 13, so if we wanted to write this, GCF of 12 comma, or not 13, 32 is equal to 4.
How do you know which number to put first in the parentheses, or does it?
It doesn't matter. I mean, usually always goes smallest to largest. Okay, GCFs. So what would be the GCF of 160?
Oh, they said 100.
100 and then 60. Oh, you're out of here. Oh, they're all from here. Hold on. What'd you guys get? 20? Does anybody need me to work that out?
No, that's pretty easy.
Alright, so the GCF is 20. Yeah, still some people working on. So 1 and 100, 2 and 50, 4 and 20, 5 and 25, and then 10.
No, it'd be 5. It'd be 5.
4 and 20 and 5 and 25.
That's not like right.
Yeah, that's what I said. 4 and then 20, 5 and 25, and then 10 and 10. 1 and 60, 2 and 30, 3 and 20, 4, does that 4 go to 60? No. 5 and what? 14? No.
Yeah.
No.
It'd be 5 and 12.
12, thank you.
And then 4 and 15.
4 and 15. So my largest is 20. Oh, it's really scattered. All right, so what happens if I now put variables in with it? So now instead of a GCF, we are now making it into a GCMF. So now what we're looking for is the greatest common monomial factor. So to find the GCMF, the greatest common monomial factor, the first step we want to do, number 1, is you're going to write the prime factorizations of each coefficient.
Please stop.
Step 2, we're going to write all the powers of the variables as products. And then step 3, then we'll find the product of the common factors.
Not like whiplash my neck. Or something like that in my head.
So GCMF is now what we're going to be throwing into the mix. All right, here we go.
Hold on. Go back here.
All right, relax.
That would just be moving your neck.
That little fat ball.
Okay, so we need to find. Here we go, guys. The GCF of 15x to the third and 9x squared. So, my coefficient of the first monomial is what? 15. So we're going to take that to prime factorization. So 15, give me 2 numbers. Thanks. 5 and 3. Are those prime numbers? Yes. So 15 is the same as 3 times 5. Then I'm going to write the product of my variable with the exponent. If I have x to the third, how many x's is that? So I'm going to rewrite that as a product of 3 x's. So if I were to multiply all this together, I would get 15x to the third, right? Yes. Okay, so we're going to do the same thing for 9. 2 numbers for 9. 3 and 3, are those both prime numbers? Yes. So 9 is the same as 3 times 3. How many x's would I have? 2. Now what we're going to do is we're going to find our matches. In the numbers, I have a matching of 3 here. And I have a match of 2 x's. So now I'm going to create a product of those matches. So my GCMF would be 3x squared. Did everybody see that? So my GCF would be 3, or GCMF, or GCF is 3x squared.
Did you just take 1 home?
So my GCF of 15x to the third, comma, 9x squared is equal to 3x squared.
My question,
What?
like what's the point of all this though?
Because when we have to factor things to solve quadratic equations, you need to be able to do this. This is your foundation to be able to solve quadratic equations. Yes.
Is this 8.2?
No, this is still 8.1.
Are we going to be learning 8.2 foundation?
Nope. We'll start at the beginning of 8.1 today. No, so your answer is just the 3x squared. Like you could just put 3x squared and circle it and say that's my answer.
What happens before the other stuff? No, because those are the ones that have in common, so it's just one of them.
Right. So it's the same thing as like dividing it out. So if I were to divide, I could divide 15 and 9 both by 3.
Oh, so
And I could divide out x squared from x third and right. So the question is, what's going to be left with those is where we're going in section 8.2.
The x squared though from...
Because I've got 2 x's.
Oh.
Okay. And then the stuff that's going to be left over is going to come into 8.2.
X squared times x squared, or plus.
Right. All right. So let's do 8x squared and 7y to the third. So 2 numbers for 8. 2 and 4. Numbers for 4.
7 and
2
1.
and 2.
2 and 2. So I get 2 times 2 times 2. How many x's?
7 and 1 for 7.
So x times x. Now do the same thing for 7. Well, 7 is just 7 and 1, so we'll put 7. How many y's?
3.
Do I have any matches?
You have to line them all up.
Well, no, I don't have anything that lines up, do I? So if I don't have anything, the GCF is not 0.
1.
It's 1. Good.
2. 3, 4. 5, 6.
Okay? All right. Here's a helpful hint. This is what I use. If you want. If you want the hint. So, if your 2 terms, guys, listen please, because this is how I do it in my brain, so I can do it quickly. If 2 terms contain the same variable raised to different powers, the GCF will contain that variable raised to the lower power. So, for example, in our first example, it was what? What do we have? 2 examples back. What was it?
15x to the third, 9x to the second.
Thank you. 9x squared were the 2 monomials that we had. What was the degree of the x in my GCF? It was 2. So it's always going to be your smallest exponent of the 2 for your GCF, which kind of makes it easy. So if I turn this into a 4, and I turned this into a 3, how many x's would they have in common? That would line up. 3, right? Because this would be 4 x's. That would be 3 x's. So then I would have 3 x's in common. If it was 6 and 2, the exponent on my GCF would be x to the second, right? Because I would only have 2 matches up. It's a nice way to think about it.
Oh, so the lower exponent.
So your smallest exponent will always be the power of your GCF. All right, so that is it. We won't do the word problem. So what I would like you to do for a classwork grade, don't worry about number 23, the word problem. Practice finding GCF. Actually, let's do this. Make your life easier. Let's make any odds. So just complete the odds right now. Exclude 23. So just do the odds. Do not do number 23. Unless you want to do the word problem. Once Marcia gets back, then you can go, yes.
Miss Crowley, are you familiar with,
Let's do the odds.
no, wait, where, no, that was Miss, what was the math teacher last year, guys? What was her name?
Origin.
Miss Archie, yeah. She was the one that knew, like, all the famous people, right?
Yeah.
Yeah. Right, let's go.
We'll have a race. Let's see if I can beat you. Just the odds. No number 23.
Just the odds.
You can do all of them if you want.
No, I'm gonna do 3. I did 1, 2, 3, 6, 9.
If all factors are prime numbers, right, this is the prime.
So 9, make your braces. 9 and 2. 9 will go to 3 and 3.
But I thought they were prime.
Those aren't prime. You're writing the prime factorizations.
So basically the factor is not the prime factor.
You're taking it to the prime factors. Look at your notes underneath prime factorization.
I know it says when all factors are prime numbers.
Yeah, and then we did some examples. Make your branches.
So I wouldn't write down 2. I wrote down like 3.
Factor tree. 9, 2, 3, 3. These are all prime numbers. That would be 2 times 3 squared.
Oh, that's what we're doing?
Why is there a line?
That's where you're writing your answer.
The prime factorization.
Wait, so 16 1.
You have an eraser?
Big Christian.
Yeah, and the shoebox up there should be in there. Why?
Wait, so I'm not supposed to do that?
So you're going to prime factorization.
What is prime?
So that's when you take it all the way down
Oh.
to prime numbers. And just like-
Wait, so Justin?
That's just the factors. Prime factors.
Sweet, the answer.
7 times 8 is 56.
I don't want to mess this.
No, no.
Wait, 7 times 8 is 5.
Wait, I have a question. What if you get the case where you have like 3?
Then you do lower.
Wait, and
Yeah.
if
No,
nothing
like,
works,
that's
it's
all
1,
I-
right?
So if nothing works, then it's just
So
right one.
I got 2, 5, and 3. 20 is
Yeah, how
5
many
times
twos?
1.
You got 2 twos, you got 2 squared. Times 3 times 5. We're only doing the odds first. So it'll be 2 times 2 times 3 times 5. Those numbers all multiplied together would be 120.
2 times
We're not
2.
supposed to do
Why would you do 3 times 5? Why would you do 2 times 3 times 5? I know it's
You're just writing them all out as factors, multiplying. So 2 times 2 times 3 times 5. 2 times 2 times 3 times 5.
No, you,
Is
it's not.
120.
Oh my god.
So wait.
I forgot.
Yeah, I mean, it goes to, 23, or 30, no, 23. times 2 times 2 times 2 times 2 times 7. 2 cubed times 7. How much time do we have to do this?
Just do the odds.
Are you gonna mix it in even?
Huh?
You know, nothing.
12 times 12.
Ah.
6 times 2, 6 times 2.
Sorry, I don't know.
So 3 times 2 squared times 2.
Wait, I'm now confused.
2.
All of your branches?
Yeah, 3. So there's 2 over here, 2,
4.
6.
I need help on 19.
1, 2,
Okay, so you're still doing the same thing.
Yeah.
So you're only gonna have 12 that's in common, right? So you have the
like, even if I
infinite product. So 12 is what? 2 times 2 times 3, 2 times 2 times 3. So you're gonna see that 9.
it's
Oi.
Well, that's the answer, 19.
What's the answer to 19? What's the answer to 19?
That was 6.
Oh, look at that time.
Wait, it's 5, 2 times 4 times 3 times 2. That's definitely wrong. What's 5?
They can take my test now.
I would prefer you be here for this so you don't miss the lesson that comes after.
Yeah, what it feels like on Friday or tomorrow, I mean, I'll forget it.
If you want to do that, just got to make sure you get
Well, like-
caught up.
Are we gonna do a lot more notes?
We are right after this, but you can get your notes off someone else if you want to do that.
Yeah, I can do that easy.
16 and 20. Exactly. So what are we doing? Oh.
In 2 seconds.
I don't know what.
You would grab a calculator. I'll put you in the pod.
Sweet.
This is annoying. Ragey. I can't do this. Zach,
Oh, that's
what did you get for 7?
Objects. 4.
4?
Yeah, what do you mean?
You got the 7.
3 is cubic.
There's degree, and then there's like 5.
17. Plus prime is
I thought they're all the same thing.
plus prime is monomial, binomial, trinomial.
And that's it.
Yeah, that's it. What? There's the constant, linear, quadratic.
That.
What? Cubic. Quintic. And then if you
Take off one pocket.
what is it divided?
Something in the bucket.
Zach, what you got on 9?
Big dog in the head.
I'm done here, sure.
Just remember those words. It's 20.
Marshall, what'd you get for 13?
Oh, 8 times.
1.
You said 8 divided by.
Huh?
What'd you get
Really?
for 13?
Yeah. I haven't done all that.
Yo,
Oh, it is hyped up on energy.
Zach, what'd you get for 13?
I haven't done it yet.
Marshall, stay on your hat right here.
No,
4 times. I got 2 thirds to the
Pretty
second.
sure it's 3. Answer's 3.
4 times 19.
you're still up.
What'd you get for 13?
13. I'm doing it right now.
What'd you feel?
What times is what?
You won. I thought of it. I thought of it. Never, ever. Disgusting.
Christian,
I've
good
got
for 9.
What I get for 9?
I'm
Oh,
just saying.
wait, this side is all. I think the greatest common
Yeah.
factors too. That you got lesson.
No, actually. I don't know if I was
Does 6 go into 78?
Yeah.
It does.
All your factors, those numbers.
78, 30.
Greatest common factor is 6. 78.
For 23.
We'll give you three.
I don't think so. I think it's just a classwork thing.
I was just confused for like photography because that'd be different, right? So 2 lots for that if we didn't do it.
Yeah.
This is quite a range.
I have a question. Would this be 5 times x to the second?
Three.
So we're working on numbers.
I don't think you would know what you're doing yet. You have to wait till we get to it, because your homework has to do with 8 too.
What? So
What's the next thing to do?
I heard.
Reverse of the distributive property.
Oh, I cannot do that.
Stop doing
Oh,
that.
dude.
Wait, actually, I think I know.
All right, if you did not get it all the way through, check your answers as we go through it.
Oh.
That's the even here. So number 1, what'd you guys come up with? 2 times 3 squared?
Yep.
Yeah.
Number 3, what'd you come up with?
Seven
So
times
30
two
times 3
thirds.
times
3 2s times 7?
Yeah.
Yeah.
What?
You didn't know
So
that?
56, what do you guys do for 56?
Look at the wrong
8 and 7, 4 and 2, 2 and 2, so you have 1, 2, 3 2s, 1, 7. 55, I would have done 12 and 12, 4 and 3, 2 and 2, 4 and 3, 2 and 2, so I have 1, 2, 3, 4 2s, 3 2s, I say 4 and write 2.
Yeah.
Okay, what's the GCF of 16 and 20?
I got 5.
4.
4, right? In my brain, what I'm thinking is what's my largest number that divides into both 16 and 20? That's how I think about it.
Yeah.
Instead of listing it out. 4. What's the largest number that divides into
1.
15 and 28?
T squared.
Largest number that divides into 33 and 66.
11.
Wait, how did
33.
33.
33.
33 goes into
Oh,
66, right?
I'm on a whole different number. That's
78 and 30?
3.
6.
6.
6 goes in both of them?
Yeah.
Let's do the math.
Right.
Okay.
Oh, that's what you get for trying to come
Now let's
up
add
with.
in a monomial.
Oh, copy off.
And number 15.
4, 5 x squared.
So the GCF of 15 and 35 is what, 5, and then you take the smallest exponent, which is x squared. What's the largest number I can divide into 6 and 9?
3. T.
3.
I made up.
My lowest t exponent is 1. Largest number I can divide into 12. 12. This has no a and b, so it would be to 0, which makes it be nothing.
How'd you
I
do
wrote
17?
17?
Yeah.
So 6, 1, 6, 2, 3. 9 is 1, 9, and 3. So my largest is 3. Then this has 1, 2, 3 t's. That has 1 t. So they have 1 t in common. It work that way? Alright, number 21. Here I have a -1 coefficient. Here I have a 3. Do I have a number that's a GCF?
So it'll be 1.
No. Now look at your m. What's your smallest m exponent? What's your smallest n exponent? 1. Good. Okay. Alright, Bridget's going to come around and collect those. Thank you, Bridget.
Any
Get
day.
those notes back out in front of you.
It's 36. Bridget, let's do that. How many minutes left in this course? Is it 36?
26.
I feel like
Oh yeah, it is 26.
We're just collecting it.
Someone else could actually go around and pick it up. Taylor.
All right, so really quickly before we get to notes, we're only going to do the first part of section 8.2, so we'll be finishing 8.2 on Friday. As we move into section 8.2, section 8.3, section 8.4, we're going to be learning a method of factoring of different types of polynomials. Thank you. So today what we're going to talk about is how to factor by a GCF. You guys just practice finding GCFs of monomials. Okay. So now we're going to get into factoring them. Now, before we do notes, I just want to do a quick chart here. Don't put this in your notes, just watch. It's not going to take very long. There we have their title and all that set up. Alright, don't put this in your notes, just watch. Do we remember how to distribute? Using the good old distributive property. 3 times x is 3x. 3 times 2 gets us to 6, right? If I ignored this and I said, what is the GCF of 3x and 6, what would you say it would be? 3. Good. Alright, now let's do this one. Distribute. X squared times x.
X to the third.
X to the third. X squared times -5. What's the GCF of these two terms?
X squared.
Yeah, because this doesn't have a number with a 5, and then you take your smallest exponent of the x's. Right? Because this would be 1, 2, 3. This would be 5 times 1 times x times x. So the only thing pairing up are your 2 x's.
Sure, how about
All right. Distribute here. What do we get?
A squared B.
A squared b. What do we get here?
2AB squared.
2ab squared. What's the GCF? What's your smallest a exponent? What's your smallest b exponent? Okay. Distribute here. What do we get? We get 5y to the 5th. Minus
40y.
Good. What's the GCF of 5 and 40?
5.
5.
A.
The GCF of y to the 5th and y squared is y squared.
wouldn't it be 8?
I am just
No,
trying.
because
H is not divided into 5, right? What do we get here?
3A to the third.
3a to the 3rd. What do we get here?
3AB.
3ab,
Plus 1.
not plus 1.
Plus 3a.
Plus 3a.
Hey. Sorry, Nick's head was
3A.
What's the GCF of 3, 3, and 3?
8.
3. Your smallest a exponent is 1. Do they all have b's? No. So now, what do you notice is the relationship between this and the factored form?
Where's the first one?
It's the number that is out in front.
Oh, true, no.
So, when we get into factoring by GCFs, factoring means we're doing what operation? Multiplication. When you are doing your prime factorization, you're writing things with things being multiplied. So when we get into our factoring, where are we at here? We're going to be writing it as a product. So remember, if you are asked to factor anything, you should be writing it as a product. So factoring means writing something as a product. Okay? So factor, multiplication, products, something times something, prime factorization, 2 times 2 times 2 times 7. Prime factorization, 3 times 5 times 7 will be prime factorization. So we're writing something as a product. Multiplication. When we do the distributive property, what's the product of these two polynomials? 2 is a, classify it. Constant monomial times a
X.
A linear.
linear binomial. So it's the product of two polynomials, right? If I had 3x squared times x squared plus 5x plus 1, I have a quadratic monomial times a quadratic trinomial, right? To turn it into a polynomial, we do the distributive property, right? So we should be able to get this to 2x plus 4, correct? Now what's going to happen, wait for this, thanks. Now we're going to have this, and now we're going to take it to this. Aiden, do you see that?
Yes, I did see that.
Right now you are able to take it from here to here, right?
Yeah, I
Now we're going to go from here to here.
backwards.
We're going to go backwards. So we're going to do the reverse of the distributive property is what we're going with right now. So, we're going to skip all that. Here we go. If I give you the quadratic binomial 2x squared minus 4, and I want to factor it.
Would there be like multiple answers to that?
Nope. There will not be multiple answers. Let's first think about what the GCF of 2x squared and 4 is going to be. Now I'm going to write it all out just for the first few. What are the prime factorizations of 2? Just 2. Good. How many x's would there be? 2. What are the prime factorizations for 4? 2 times 2. Ignore the negative for now. So the GCF would be what? Just a 2. There are no x's there. X is the 0, right? So what's going to be the number that's in front of the parenthesis? 2. So this is equal to 2 times. Now if I eliminate this 2 out of the 2x squared, what's left over? X squared. Now bring down your minus. If I eliminate the 2 from the 4, what's left over? The 2. I just did the reverse of the distributive property.
We're dividing, right?
Yeah. Okay. Or another way that you can think about it, once you get this 2, just divide out the 2 from everything. It's just dividing. It's the same as eliminating. If I divide 2x squared by 2, I'm left with x squared. If I divide 4 by 2, it's 2. Because what's the reverse of multiplication? Division, right? All right, so now it's going to be, I have 8x to the third minus 4x squared minus 16x. Now focus just on the numbers first. I've got an 8, I've got a 4, and I've got a 16. What's the largest number that will divide into all 3 of those numbers? 4, right? So I'm going to put a 4 in front of my parentheses. What's going to be the exponent on the variable x?
2.
Go with always the smallest. 3, 2, 1. So I have 1 left over. All right. So if I divide 8 by 4, or if I think in my head, 4 times what gets me to 8, it would be 2. X times x gets us to x to the third. X squared. Good. So continually keep checking. 4x times 2x. Yep, did that right. Okay. Bring down your minus. 1x. Good. Because this would get you to 4x squared.
Yes.
Does everybody see that? Minus 16 divided by 4 is 4. If I eliminate the x, I have no more x's. If I redistribute and check it, it gets me to there. Okay. If you want to write out the prime factorizations each time, feel free to do that. 8 is 2 times 2 times 2, and then 3 x's. 4 would be 2 times 2 with 2 x's. 16 is 4 2's with 1 x. and then make your pairs, pair, pair.
I still don't get why.
That's not another pair.
That is not another pair, thank you.
I still don't get why you have to go backwards.
Because we need to be able to solve quadratic equations. And you solve quadratic equations by factoring. We're not there yet. We're building the foundations to be able to handle these type of
How does
equations.
going back to that help you find that?
How
How's going back to that help you find stuff below?
So what I'm doing is I'm taking this to its prime factorization. I'm taking this to the prime factorization. Taking this to the prime factorization. So 2 times 2 is 4. Huh? And I got a pair of x's. Guys, relax. So that's why it's 4x. And then what's left over for my first term? 2 with 2 x's. What's left over in my middle term? Just 1x. What's left over in my bottom term? 2 times 2. So the stuff that's left over from the pairings is what goes on inside. All right, let's try another one. 14x minus 12x squared. What's the largest number that divides into 14 and 12? GCF, you're fine, is 2, right? How many x's can I take out? I only can take out 1. You always take out the smallest. So 2x goes out in front. All right. 2x times what is 14x squared?
7.
Good. Bring down your minus. 2x times what is 12x squared? 6x. Done. You can always check your work by then redistributing it and making sure you get back to where you started. All right. D. 3x to the third plus 2x squared minus 10. So is there anything that we can factor out? No. If I wrote it as 1 times that, it really would not be the factored form. So when you get to something like this, you write not factorable.
Wait, why is it not?
Because there is no GCF for all of those terms. Because I can't write it as the product of 2 things. Guys, please stay with me. All right. Let's get them a little bit more complicated. These are the last 2. Last 2. Here we go.
Oh, 5.
So we got 15x to the third, guys, plus 5x squared minus 20y squared. Focus on the numbers first. 15, 5, and 20. The GCF would be 5. Now let's focus on the variables. Do they all have x's? No. So I can't take out an x. Do they all have y's? No. So I can't take out a y. So the only thing that the GCF is 5. So now 5 times what is 15? 3. Bring down your x to the third y. Plus 5 times what is 5? 1x squared. Bring down your minus. 5 times what is 20? 4. Bring down your y squared. Done.
Can you not understand what you're saying?
Sure.
Let me think about it.
Wait, how is there nothing next to the 5 again?
Because they don't all have X.
Because this has an x to the third, so this has 3 x's and 1 y.
So they all need to have
Right, this has 2 x's, this has 2 y's. So I can't match. I can't get a pairing of x in all of them. I can't get a pairing of y out of all of them. Are you good, Aiden? All right. Last one. 6, 10, and 6. What's the GCF? 2. Good. What's your smallest exponent on the A? 2. They all have an A. I see an A here, I see an A here, I see an A here. My smallest exponent is A squared. Do they all have B's? The smallest exponent is B to the first. So that's going to be the monomial that's out in front. 2 times what is 6? 3. If I had 4 A's and I took 2 A's out, I'm going to be left with how many? So A squared. If I had 1 B and I took a B out, would I have any left over? No. Bring down your minus. 2 times what is 10? 5. If I had 3 A's and I took 2 out, I'm going to be left with 1. If I had 2 B's, take out a B, I'm left with 1 B. Bring down your minus. 2 times what is 6? 3. If I had 2's, take out 2, no A's. 3 B's, take out a B, B squared. Done. All right.